Hi, my name is Keshav Busal, and today I am presenting my individual case study on the system analysis and design of an e-voting application. In the presentation, I will briefly walk through the problem with traditional voting, the system requirements, the analysis and design models, and finally the ethical and security considerations of the system. To begin, I will start by explaining why an e-voting system is required at the first place. So I choose the e-voting system because voting is something that affects all of us as a citizen. Traditional voting system faces several challenges such as long queues, manual counting errors, high operational cost, and limited accessibility, especially for elderly voters and people living in remote areas. As shown in the image on the slide, e-voting replaces these manual time-consuming processes with a secure digital platform where voters can authenticate themselves, cast their votes electronically, and have it counted instantly. This is why an e-voting system is considered a secure, efficient, and accessible solution supporting both remote and on-site voting while delivering faster and more reliable results. Now that the problem is clear, I will move on to explain what this system actually covers and who are involved as a key stakeholders. So here, the scope of this system focuses on the complete voting life cycle. This includes voter registration and authentication, secure vote casting, encrypted vote storage, and result calculation and reporting. The key stakeholders are voters, the election commission, system administrators, and auditors. Each stakeholder interact with the system differently, which makes identifying them important during the analysis phase. Once the scope is defined, the next step is identifying what the system must do and how well it must perform. The system requirement are divided into functional requirement and non-functional requirement. Functional requirement include user registration, secure login, using multi-factor authentication, vote casting with one voter or one vote per voter, and automatic result generation. Similarly, non-functional requirement focus on system quality such as security through encryption, high reliability and availability, good performance during peak voting times, and compliance with legal and ethical standards. Together, this requirement ensure the system is secure, scalable, and trustworthy. After defining the requirement, the next step is to analyze how the system analysis work. The system analysis model shows the interaction between voters, election authorities, administrators, and e-voting system itself. For example, voters submit registration details and votes, while administrators manage election and election authorities receive verified results. This model helps clearly define system boundaries and data flows before moving into detailed design. Here, the next slide shows the ER diagram. The ER diagram represents the system's data structures. Key entities include voter, election, candidate, and vote, with relationship designed to ensure one vote per voter per election. This data model is critical for maintaining data integrity, preventing duplicate voting, and ensuring accurate election result. After designing the data model, I then focused on how users actually interact with the system via UML use case design diagram. So here, the use case diagram shows the system from a user's perspective. Here, from the user's perspective, the two main actors are the voter and the administrator. The two main actors are the voter and the administrator. As we discuss here, voter can register, log in, cast votes, and view results, while administrators manage election and system operation during the election time. This diagram clearly defines the role and permissions, making the system easier to understand and validate. Next, I will briefly explain the assumptions which were made and the design decision which were taken while doing this all model. So some assumptions include user having internet access, availability of government approved voter ID, and the use of secure servers. Based on this assumption, I choose a web-based authenticator, implemented encrypted word storage, and applied role-based access control. These decisions help balance security, usability, and system efficiency. Because this is a voting system, it is also important to address ethic, security, and legal compliances. So here, ethic means from the ethical perspective, the system must ensure voter privacy and anonymity, so votes cannot be linked back to individuals. From a security perspective, features such as end-to-end encryption, secure authentication, and audit logs protect against tampering and vote fraud. Legally, the system must comply with electoral laws and data protection regulation, which is essential for public trust. Finally, I will conclude by summarizing the overall value of the given system. To conclude, the e-voting system demonstrates how effective system analysis and design can improve efficiency, accuracy, and accessibility in elections. By using structured models such as DFD, ER diagram, and UML use case, the system becomes more secure and transparent. Overall, a well-designed e-voting application can modernize democratic processes while maintaining integrity and trust. That's my time. Thank you for listening me out.